Welcome, friends. Let us go into the topic. First of all, this is Institute of Aeronautical Engineering IARE. Let us discuss about the equivalent inductance of series and parallel inductors with mutual inductance presented by B. Harshavardhan Yadav 22951A. 6737 series and parallel inductors. Now we see the voltage and L1, L2, L3. These are connected in parallel. Now we see the series connection of the inductors. When inductors are connected in series, the equivalent inductance of the combination will be the sum of all individual inductance. This is just like the equivalent resistance of series connected resistors. But in the case of inductors, we sometimes have to consider the effect of mutual inductance between the inductors. This is just like the equivalent resistance of series connected resistors. But in the case of inductors, we sometimes have to consider the effect of mutual inductance between the inductors. Then, to calculate the inductance of each inductor, we consider both the self-inductance and mutual inductance of inductor. The mutual inductance will be either added or subtracted from the self-inductance depending on magnetically coupled inductor's polarity. We will learn about the effect of mutual inductance later in this article. Now, we with, Now without considering mutual inductances, we can write the equivalent inductance of series in connected inductors as Leq is equal to L1 plus L2 plus L3 plus L4 plus L5 plus up to so on plus Ln. When inductors are connected in parallel, the reciprocal of the equivalent inductance of the combination will be the sum of individual inductances reciprocal. This is just like the equivalent resistance of parallel connected resistors. We may also have to consider the effect of mutual inductance in the same way if required. We will learn the effect of mutual inductance on parallel inductors later in this article. Without considering the effect of mutual inductances, we can write 1 by Leq is equal to 1 by L1 plus 1 by L2 plus 1 by L3 plus 1 by L4 plus up to so on plus 1 by Ln. An inductor is a passive circuit element. Let us find out the equivalent inductance of series connected and parallel connected inductors. Adding inductors in series. Let us consider n number of inductors connected in series as shown below. Now L1, L2, L3, L4 play up to so on Ln. The inductors are connected in series and voltage also across the each inductor V1, V2, V3, V4, V5 up to Vn. respectively. Now we apply Kirchhoff voltage law. We get total voltage drop V across the series combination of the inductors. Now this is the KVL we learned in the earlier classes. Let us now recall it. V is equal to V1 plus V2 plus V3 up to so on. It is the Kirchhoff voltage law. LEQ is equal to L1 plus L2 plus L3 plus L4 plus up to so on plus Ln. The voltage drop across an inductor of inductance. The voltage drop across an inductor of inductance L can be expressed as L into d1 by d2. As all inductors of the combinations are connected in series, the current through each of the inductors in the same and say it is also so. From the above KVL equation we get V is equal to L1 di by dt plus L2 di by dt plus L3 di by dt plus L4 di by dt plus up to so on plus Ln di by dt. Let us discuss the rewritten equation. This equation can be rewritten as V is equal to L1 plus L2 plus L3 plus L4 plus up to so on plus Ln into di by dt. Now this can be represented as mathematically sigma k is equal to 1 to n L suffix k into di by dt is equal to Leq di by dt, where Leq is the equivalent inductance of the series combined inductors. Hence, Leq is equal to L1 plus L2 plus L3 plus L4 plus up to so on plus Ln. The equivalent inductance of series connected inductors is simply the arithmetic sum of the inductance of individual inductors. This is same as the for the parallel inductance. V1 by L is equal to 1 by L1 plus 1 by L2 plus 1 by L3 plus up to so on plus 1 by Ln. Now V is equal to 1 by L1 plus 1 by L2 plus 1 by L3 plus 1 by L4 plus up to so on plus 1 by Ln into di by dt. Now totally V is equal to 1 by Leq into di by dt. This is the parallel connection of the inductors that are done by the in the presence of the KVL law. This is the this is the series and parallel connection of the inductors. The inductance are two types. They are mutual inductance and self inductance. These are worked on the presence of the mutual inductance.